Hello students, my name is Pradeep Kumar and I teach mathematics. So today the topic which we are going to see is compound angles, and some of the most important fundamental formulas of trigonometry. So these are like building blocks of trigonometry from which we derive many other formulas, right? So let us get started. So first of all, let me tell you what is the meaning of a compound angle. So a compound angle is nothing but an algebraic sum of two or more angles. Let's say we have angle A, angle B. You have A plus B, A minus B. If you have three angles, it's A plus B plus C, or A plus B minus C, or A minus B plus C, and so on. So these are called compound angles, where you have combination of two angles, two or more angles. So in general, we deal mainly with these two, when we have two such angles, angle A and angle B. So these are the four very important formulas. They are sin of A plus B, sin of A minus B, cos of A plus B, and cos of A minus B. So these are the formulas which form the basis for deriving many other formulas, right? Even for multiple and submultiple angles, which is going to come next, and also even for conversion from sum to product, product to sum. These formulas are what we are going to use. So now let us understand how we can prove them. There are several ways we can prove them. So one of the ways is we will try to prove this formula, cos of A plus B. Cos of A plus B is equals to cosA.cosB minus sinA.sinB. And with the help of this, we can actually prove the remaining three formulas as well, right? So here I am assuming the basic background knowledge of what is the definition of cos A, what is the definition of sin A, how do we define them, and also I am assuming that you know the reduction formula. That means cos of 90 plus theta, cos of 90 minus theta, sin of 90 minus A, sin of 180 plus A, all these things. So those things will come before this. They are trigonometric ratios and reduction formulas. So I am assuming that you all know that, and with that assumption in mind, let us prove this formula, and with the help of this we can actually prove other three formulas as well, right? So let us get started. So cos of A plus B is equals to cosA.cosB minus sinA.sinB. So to prove this, okay, let us consider a unit circle. Let us consider a circle of unit radius. So where we have the points, the center of the circle is origin and the radius is 1 unit. So center is origin and the radius is 1. So this is going to be 1, 0. This is x-axis, this is y-axis. And now let's say we have a point P which makes an angle. Let's say OP makes an angle. OP makes an angle. Let's call this point as A. Or let us call this point as what shall I say? Let us call it as L, right? Let us say this angle is capital A. So now by the definition of trigonometric functions, we know that cos A, what is cos of A? Cos of A is x coordinate of this upon the distance. So x coordinate upon 1, because OP is 1 unit, OP is radius. So x coordinate upon 1 is cos A. So x coordinate is nothing but cos A. So this is cos A. And y coordinate is sin A. This comes from the definition of cos A and sin A. So now let us take angle B as well. So suppose it's from point P, if we move angle B in anti-clockwise direction. So let's say we arrive at the point Q. So let's say this is point Q. So this angle is again angle B, right? So now if we want the coordinates of Q, by the same procedure, if this angle is A, the coordinates are going to be cos A, sin A. Now the total angle is angle A plus angle B. The total angle is A plus B. The coordinates of Q are going to be cos of A plus B, sin of A plus B. So these are going to be coordinates of Q. Now let us take one more point, which is, let's say, which is making angle B, but in anti-clockwise direction. So this is minus B. Let us call this point as R. So the coordinates of R are going to be cos of minus b comma sin of minus b, isn't it? Because the angle in anti-clockwise direction is measured as positive and the angle in clockwise direction is measured negative. Suppose if you move b units downwards, that means in clockwise direction, so this angle is going to be measured as minus b, and the coordinates of this point are going to be cos of minus b comma sin of minus b, and we know that cos of minus theta is same as cos theta and sin of minus theta is same as minus sin theta. So that is going to be, our coordinates are going to be cos b comma minus sin b. So these definitions and the reduction formula which we have done previously, right? So this is the background. Now from this we want to find formula for cos of a plus b. So now you see, let me complete these two triangles. One triangle is triangle LOQ, triangle LOQ, and another triangle is triangle POR, triangle POR. So now you see, in triangle LOQ, triangle POR, these are the two triangles we have. So triangle LOQ is going to be an isosceles triangle because LO is 1 unit, OQ is also 1 unit because of the radius, because they both are radius, and vertical angle, these two sides are equal, the vertical angle is A plus B. So angle LOQ. So in this we have OL and OQ as 1 unit each, and angle LOQ is A plus B, angle A plus angle B, A plus B. Now let us consider OPR, triangle POR. So in triangle POR, so we can say these things, right? So PO and OR both are equal to 1, that is also going to be an isosceles triangle, and you see the vertical angle is going to be A plus B because you are moving A units in anti-clockwise minus or B units in clockwise. So the total difference between them would be A plus B, because this is the reference. From reference you are going A units this way and B units this way. So the total difference between them would be A plus B. Just like from 0 you are going 2 units minus 2, you are going to minus 2, and you are going to plus 4. So then what is the total distance between them? That is going to be plus 6, because 4 minus of minus 2, that is plus 6. So in the same way, this angle is going to be A plus B, because 4 units upwards or anti-clockwise and 2 units clockwise. So it is going to be addition of these two, A plus B, or A minus of minus B, right? That is A plus B. The total angle would be 6 units, for example. So now from this we can say that these two triangles are congruent triangles. We can say triangle LOQ and triangle LOQ is congruent with triangle POR. The reason is simple. You see, LO is equals to, we can say PO, both are equal to 1. So LO is equal to PO, that is equal to 1. Both are 1 because the radius. And then we have, we can say OQ is equals to OR, both are equals to 1. And we can also say the angle, included angle LOQ is equal to angle POR, which is nothing but A plus B. So you see, the two sides are equal and the angle between them is also equal, isn't it? LO is equal to PO and OQ is equal to OR. Angle between LO and LOQ is equal to angle POR. So side angle side congruence, SAS congruence. So from this we can say that these two triangles, triangle LOQ and triangle POR, congruent triangles. So from this we can easily say that QL is going to be equal to PR. So from this we can conclude that QL is going to be equals to PR, because QL is the base in the first triangle and PR is the base in the second triangle. They must be equal because the two triangles are congruent. So now let us equate the two distances. QL is equals to PR. So now to find distance between 2 points, we need distance formula. So in 10th class, you all know that distance between 2 points x1, y1 and x2, y2 is root over x1 minus x2 whole square plus y1 minus y2 whole square. So we can use that formula to find this distance as well as this distance and equate them both, right? So just let me remove this so that I can write this part here. So now we have the conclusion. The conclusion was QL is equals to PR. QL is equals to PR. So now let us find QL. So QL is nothing but root over x1 minus x2 whole square plus y1 minus y2 whole square. x1, y1, x2, y2. So x1 is cos of A plus B. Cos of A plus B minus 1 whole square plus sin of A plus B minus 0 whole square. So this is QL, x1 minus x2 whole square plus y1 minus y2 whole square. So this is QL, distance between Q and L. And similarly P and R, so the distance PR would be equal to root over x1 minus x2 whole square, y1 minus y2 whole square. So cos A minus cos B, cos A minus cos B whole square plus sin A minus of minus sin B, which is plus sin B, sin A plus sin B whole square. So now if you equate these two, so the root will get cancelled because on both sides root is there. So we can just equate whatever is inside the root. So now here you see there is A minus B whole square formula. Here we will end up with 3 terms. Cos square of A plus B minus 2 cos A plus B plus 1, A minus B whole square formula. And then we have sin square. So cos square plus sin square. So the first term from this and this, because there is just one term over here, sin square of A plus B. So cos square plus sin square is going to be 1. So 1. Then here the middle term will come, that is minus 2 into 1 into cos of A plus B plus minus 1 whole square, that is plus 1. So here we have A square minus 2AB plus B square. Here this cos square plus sin square is going to be 1. So that's why I wrote 1 here. Minus 2 times 1 into this plus 1 plus 1. This is going to be equal to this. So in this there will be 6 terms. 3 terms from this and 3 terms from this, isn't it? So the 3 terms from here are cos square A minus 2 cos A cos B cos square B, the 3 terms A minus B whole square, cos square A minus 2 cos A cos B plus cos square B. And the 3 terms which we are going to get here are A plus B whole square, sin square A plus 2 sin A sin B plus sin square B. Now you see cos square A plus sin square A, that is going to be 1, right? So 1 plus, next let us write the middle terms later, cos square B plus sin square B, that is going to be 1, right? Because here the last term is cos square B, last term is cos sin square B. So that is going to give us another 1 plus here the middle term is going to be minus 2 cos A cos B. So we have minus 2 cos A cos B plus the middle term here is going to be 2 sin A sin B. So we have plus 2 sin A sin B plus 2 sin A sin B. So that's it. Now here plus 1 plus 1, 2, 2 and 2 will get cancelled. So here we have minus 2, divide the entire equation with minus 2. So anyway this plus 1 will get cancelled, divide the entire equation with minus 2. So here this minus 2 will go away. So we will end up with cos of A plus B is equal to cos of cos A cos B, cos A cos B minus sin A sin B. Minus sin A sin B, because here we have plus 2. When you divide 2 with minus 2, 1 minus will remain. So this is the formula for cos of A plus B. So cos of A plus B is cos A cos B minus sin A sin B. So this is how we derive cos of A plus B formula using this. There are many other ways we can do this. This is one of the ways, right? So cos of A plus B is equal to cos A cos B minus sin A sin B. in JEE mains and advanced you may not require to prove this, but you need this result. This final result is very important, right? Especially for mains and advanced. For board also they may not ask you to prove this, but they may give questions based on this, right? So now with the help of this we can actually prove the remaining three formulas very easily, right? How? Let us see that. So clear? So this is how we can prove it. So in case if you have anything to ask, you can freely ask this. So okay. So in case you did not understand any step, so you can ask me, I'll explain. So okay, next one is, so with the help of this we can easily prove cos of A minus B formula. So we got this formula, cos of A plus B. Cos of A plus B is cos A cos B minus sin A sin B. So now if we want cos of A minus B, so cos of A minus B, what we do is we just replace B with minus B. So just replace B with minus of B. So in this formula, in the first formula, just replace B with minus B. So this will become cos of A plus minus B is equals to cos A cos of minus B minus sin A into sin of minus B. So you see, now again we can use reduction formulas. Cos of minus B is same as cos B and sin of minus B is minus sin B. So the cos and secant will absorb the minus. Sin, tan, cot and cosecant will give out the minus, right? So we have seen in the previous classes. So sin of minus B is going to be minus sin B. So minus into minus it is going to be plus. So we end up with cos A cos B. Cos of minus B is cos B. Cos A cos B minus into minus plus sin A sin B. So this is how we can easily prove the second formula. Cos of A minus B is equal to cos A cos B plus sin A sin B. So similarly we can actually prove sin of A plus B and sin of A minus B as well easily. So how do we do that? I'll just tell you how to do this. So this is the second one, right? So the third one is sin of A plus B. So sin of A plus B is, so I'll just tell you the procedure to do it. So I'll leave it for you as a homework. So sin of, we can write it like this, sin of, can we write it, okay, so sin of A plus B, we can convert it to cos, right? So we know sin theta is equal to cos of pi by 2 minus theta. So we can use that here. So cos of pi by 2 minus of A plus B. Cos of minus pi by 2 minus of A plus B. So this I am modifying it slightly because we know sin theta is equal to cos of pi by 2 minus theta. So this is going to be pi by 2 minus A, pi by 2 minus A minus B. So now you see this is one angle. Consider this as one angle, consider this as second angle. So it is like, it is, this complete is angle A, pi by 2 minus A, treat it as A, minus B, B is B. So now in this formula we can just replace A with pi by 2 minus A and B with B, because in place of A we have pi by 2 minus A. So we can use this formula which we derived just now. So we can write it as cos of pi by 2 minus A into cos B into cos B into cos B plus sin of pi by 2 minus A into sin B. So that's it. We got the formula, right? So this is cos of, so treat this as a single angle, treat this as another angle. So we have cos of pi by 2 minus A into cos B plus sin of pi by 2 minus A into sin B. Only difference is A is replaced with pi by 2 minus A in this formula. So A is replaced with pi by 2 minus A. So whatever A, wherever A is there, you have to replace it with pi by 2 minus A. So pi by 2 minus A, pi by 2 minus A. So that's it. So now we know cos of pi by 2 minus a is sin a. So this is going to be sin a cos b, and this is cos a sin b, cos a sin b. So this is the third formula. Sin of a plus b is sin a cos b plus cos a sin b. To get sin of a minus b, what we can do is we can just replace b with minus b. So just replace b with minus b, you will get sin of a minus b as sin a cos of minus b. Cos of minus b is same as cos b, plus cos a sin of minus b. So sin of minus b is minus sin b, minus will come outside. So the only difference between sin of a plus b and sin of a minus b is the minus over here. So sin of a minus b would have the two terms same, but only the difference is in place of minus we will have, in place of plus here we will have a minus in the fourth formula, right? So this is how we can easily prove these four formulas. So as such, you should know the final results. Final results are most important, right? Because they will form the basis for many other, to derive many other formulas, right? So we can see some examples also. The applications of this are like, you can find suppose a sine, if you want to find sine 15 degrees or sine 75 degrees or cos 15 degrees, cos 75 degrees. So those places this will be helpful. So just let us see a quick example where we can use these formulas. So suppose if someone asks you to find cos 15 degrees or cos 75 degrees. So to find the value of cos 75 degrees, we can write 75 degrees as cos of 45 degrees plus 30 degrees. Because we know the values for cos 45 and cos 30, sin 45 as well as sin 30. So we can just write it in this form, 75 as 45 plus 30. We can apply this formula. So this is going to be cos 45 into cos 30 minus sin 45 into sin 30 degrees. So that's it. A is 45, B is 30. That's it. So we know the values, 1 upon root 2 into root 3 by 2 minus 1 over root 2 into 1 by 2. Sin 30 is half, right? So that's it. The answer is root 3 minus 1 upon 2 root 2. So similarly, you can find even for cos 15 degrees. So for cos 15 degrees, what is the change? The only change is it is going to be 45 minus 30 degrees. So here you will have minus, and the only change that is going to occur is here it will become plus. Cos of a minus b formula is cos a cos b plus sin a sin b. So it will become plus. The only difference is going to be root 3 plus 1 by 2 root 2 when you have cos 15 degrees. So cos 15 is root 3 plus 1 by 2 root 2. Cos 75 is root 3 minus 1 by 2 root 2. So that's it. These are the applications. So we can do similarly for tan of a plus b and so on. So that's it for today, right?